welcome to my video. Today I'm going to be designing the chassis ready for calculations. We call it FEM, F-E-M, which basically means that you can put forces on the chassis and calculate how strong it is. And for that we need to design the model, and furthermore, to help us design the final details on the chassis itself, it's also nice to have a model. And today I'm going to be talking about the different things that are important for the design of this chassis. First, a little disclaimer regarding how I make my model. Now, I know that a lot of you will probably see me working and say, wow, you got weldment profiles and weldment, you can make a chassis much easier using weldments. Yes, in theory that is true, but if you know you need to calculate with the chassis, I prefer not to use weldments. I prefer to use solid bodies. Why? Because you can work much more easily with sheet metal parts included into the design of the chassis for gusseting and that sort of stuff. And also it's just easier. It's more work, but in the end it's easier. Now regarding the chassis itself, the design of the chassis is more or less like a monocoque, and it needs to be narrow and it needs to be small and it needs to house everything that is required for the packaging. What makes this difficult is that I want to have quite a large steering angle so that I can use it for drifting and parking in tight parking spaces in the city. That's one. Two, we are going to put different body styles on it, and the body styles that I showed in a previous video, like the old race car and the hot rod, they have very narrow bodies. So the chassis itself needs to be very narrow in its basic design, and basically the front bumper and rear bumper support is what makes the chassis longer, and depending on the body style, the body that I'm working on currently can have a large side protection system, but on a hot rod, for example, there's no space for a side protection bar. So the chassis in itself needs to be very narrow and very strong. And why that is difficult is, for example, if you look at a modern car, you will see that, for example, the nose, the front bumper is 1 meter away from your feet, and that's basically your crumple zone. However, if you look at the side, maybe it's 15 centimeters to your shoulder, but your door cannot deform too much, because then they cannot open it after you have crashed, and then the firemen have to cut off the roof of the car to get to you. So the side impact is really difficult, and my chassis also needs to be very narrow, so that makes it even more difficult. So yeah, that's basically some of the just in right now those are a few difficulties. Then looking at the suspension, what would be ideal is that we would have drive shafts. However, I think we are going for a solid axle in the back, like a go-kart axle. And that means that the entire axle needs to move up and down in the chassis, so the chassis needs to go over and around the rear axle. So that's also something we need to keep in mind. couple of days back I already started with the base frame of the chassis. So there's a little bit of measurements already designed in the chassis, and of course I already had a basic chassis ready. However, that chassis needs to be a little bit lower, and I need a little bit more space for the leg room that I require. So I need to change some things, and that's what I looked for in the previous design. And at this point in time we are just finalizing the entirety of the chassis, and basically the front of the chassis is completely figured out, and the rear of the chassis is completely not figured out at this point in time, because as I mentioned before, with the solid rear axle it will go into the frame when it goes up and down. Now this car will have very little suspension travel because it has a big amount of tire and it's very light, and it won't be going very fast, and it's a sport car, so it doesn't need a lot of suspension travel. So I think that with what we achieved in the end, it will be fine. It however requires us to redesign the engine layout, the electric motor layout, and the sprocket layout a little bit. I now have a dual chain just because of the torque and because I thought it looked cool, but I think we should go for a single chain and a single sprocket setup. Then we can build a little bit narrower, just like the disc brake setup. And for the disc brake setup we need to keep in mind that we are putting two calipers on, one for regular braking, one for the hydraulic e-brake. So those will be mounted at the bottom, I guess, because there is where I have some space. And yeah, we need to keep in mind the battery pack. I want to try and make the battery pack a little bit wider, so I have a little bit more options for battery choices. And yeah, so several things to think about. And for now, this is basically the chassis design that it is. And we need to change some of the packaging that's there, and then we can start thinking about suspension pickup points at the rear and at the front, and start getting this thing together. Thank you so much for watching. I hope you enjoyed this video. If you do, please give it a thumbs up. I hope that you like some of the thoughts that I have. Please know that I'm not a SolidWorks expert. I'm just someone who works with SolidWorks a lot, and everybody who works with SolidWorks a lot has his own way of working. This is how we work at the company I work for. This is how I work personally. And yeah, if you have some comments, some ideas, if you learned some new things, please let me know. Thank you for watching again, and see you in the next video. Thank you. Bye.